Hi friends, today we are going to see a topic on Arduino interfacing with the LCD displays. The LCD displays play a major role in interfacing with our Arduino or any microcontroller so that you can view the outputs that are being obtained using sensors or actuators. The LCD stands for Liquid Crystal Display, and this is the diagram of an LCD. And we are going to see about the different pins that are available in LCD in detail. First, we'll see what are the pins available. First is the ground pin, the supply pin, which is VCC, V0, which is used to control the display contrast. For this, we'll be using a potentiometer. Next is your register select. We'll be looking at that, which is used for command and for sending the code. Then you have the read write option, where you're going to either read the data from the display or write the data into the display. E is for enabling the different registers available in your particular LCD, and these are the different registers D0 to D7. Then you have your A and K, which is your anode and cathode, which is for the different individual LEDs available in the particular LCD. So this is also a part of your LCD display. Now we look into the particular pins in detail. First is your particular ground pin, and you see that you have your particular ground pin, which is at the top left right corner, and the second pin is your supply pin, which is connected to 5 volt, and this is also being provided from your Arduino board. Next we have the pin V0, which can be attached to the potentiometer. A potentiometer has 3 different pins. The left pin is connected to the supply, the right pin is connected to the ground, and the center pin is connected to the Arduino pin, and here it is connected to the potentiometer from the LCD display, and the LCD V0 is connected to the potentiometer, where you're going to adjust the brightness of your particular potentiometer. Next you have the RS pin, which is called the register select pin. This is going to select the register either whether it is going to send data or it is going to send commands. So when the particular value given to the RS pin is 0, it is understood that commands are being provided to the LCD. So these commands could be like cursor, pointing the cursor to a specific location, clearing the display, turning off the display, and so on. So all these are commands that are provided when the RS pin is provided 0. When the RS pin is provided a high volt, that is 5 volt, then it means that data can be sent to the particular LED. So there are two types of instructions that are provided through the RS pin. Either you send the command first and then you send the data. For sending the command, you will be setting the RS value to 0. Then for sending the particular data that is to be displayed after that, you will be setting the RS value to 1. That is only when your particular characters are being displayed. Your next is your read write command. In this option, you have two ways in which either you can read the particular data or you can write the particular data from the LCD. And if you want to write a particular data into the particular LCD, you should make sure that the value is 0. That is why you have the R bar, W bar. So R stands for read and W stands for write. And when your value is 1, it means it is doing a read operation. When the W value is 0, it means it is doing the write operation. So read bar write. So when it is 0, it means write operation. When it is 1, it means read operation is done over there. We will normally be using the LCD for writing a particular data into that particular LCD. So we will make sure that our particular read bar write value is 0. Next we have the enable pin. This is to make sure that the register is enabled and the data that is sent at that particular register of time is being displayed in the particular registers. So if this enable pin is disabled, we will not be getting any other data which will be considered as noise, and the D0 to D7 will not receive that particular value. When this E pin is around 1 only, you will be the data provided to D0 to D7 will be considered, and this D0 to D7 data could be either command or it could be a data. This is what we saw in the previous register select available. Next is our last one, which is the anode cathode, which is to display the particular anode and cathode backlight contrast. So depending on our value available, we will be the display value will be available. So this is controlled with the help of a resistor that we can see with the help of a diagram. This is the LCD display interface with your Arduino Uno, and the pins that are connected to this particular Uno are 12, 11, 5, 4, 3, 2. So these are the different pins of your Arduino that are being connected to the LCD display over here. Pin number 12 is connected to a particular register select. Pin number 11 is connected, the yellow wire is connected to the enable pin. Pin number 5, 4, 3 and 2 are connected to the DB4, DB5, DB6 and DB7, which are nothing but your registers. And these registers are not, they are the entire register set is from R0 to R7. We are going to use R4 to R7 over here. So these are the 4 pins that are connected to the different registers available. Then you see that you have a potentiometer over here. As I told you, the left pin is connected to the supply and the right pin is connected to the ground, and the center pin is connected to your particular V0 pin. So this particular V0 pin is going to get the particular power supply through the potentiometer value available over here. So this will be determining the contrast of this particular display. Next, you see that you have a resistor over here. This resistor now considered is a 220 ohm resistor, and this is connected to the positive and the cathode is connected to the negative. So the anode is connected through the resistor to the positive and the negative is connected to the cathode. So this is your forward biased LED that is available over here, and depending on your resistor value, if your resistor value is high, the display value is going to be low, brightness is going to be low. If your resistor value is low, the brightness is going to be high. So this is because it is determined by the current flowing through the resistor. If the current is low because of the high resistor value, the display is going to be low. And if the current flowing is high because of the resistor value being low, the display value is going to be high over here. And as the other remaining pin, you have your ground pin and your supply pin connected over here to the different parts of your LCD display with the breadboard. And this is the connection that we just saw now. These are the different connections available over here, and register select enable pin D4 to D7, your read write operation, your VSS, that is your ground, your VCC, your V0, which is your potential center pin, and your 220 ohm between the anode and cathode. This is what we saw here. And we are going to implement this particular program to display hello world on your particular LCD display. As we saw till now, we know that 12, 11, 5, 4, 3, 2 are the pins that were connected to my particular Arduino. Void setup means one-time instruction being executed. Void loop means it is going to repeat again and again. So what is my first step required is I have to provide my initialization for my particular liquid crystal. So I'm going to use a hex library file, liquidcrystal.h, through which only my liquid crystal display is enabled. If I don't give this line in my particular program, the LCD will not work. Next is my pins that are connected, 6 different pins which were connected over there. Then I have my void setup, one-time instruction. In this I have my LCD begin 16,2, which means that there are 2 columns and 16, there are 2 rows and 16 columns available in my LCD. So that is enabled by my LCD begin 16,2, which means 16 columns and 2 rows. Next, I have LCD print hello world. This is the content that is to be displayed. Where am I going to display is what I am going to specify in my void loop. So LCD set cursor 0, 1, which means 0, 1 means in my 0th row, which is my first row and my first column. So my row starts with 0, which is 0 and 1, and my particular column is 0 and my particular row is 1 over here. So this is my 1th row available and 0th column. So this is where I'm going to display the hello world, and beyond that I'm going to, in my second row, what I'm going to do is I'm going to display after every 1 second I'm going to display 1. After the second I'm going to display 2 and so on. So this is being taken care by this LCD print over here. So now we'll go and see this with an online tool which is called Tinkercad. Tinkercad is an online open source tool through which I'm going to explain this particular LCD interface with your Arduino. So as I showed you in the earlier diagram, the same diagram out there, this is your particular LCD, 12 connected to your RS, your 11 connected to enable, and all these pins connected, all the same diagram out there. And in this particular code, I have the same code that I showed you till now. This is my particular code available over here. And with this particular code, what I'm going to do is I'm going to now run this particular program where I'm going to display hello world available over here. So when I start simulation, I see that the hello world is now displayed over here. This was what I gave in my particular program, and the milliseconds is what is running over here. So when it comes to 1000 milliseconds, what happens is 1 gets enabled over here. So when it goes to 2000 milliseconds, what happens is I get an initial value of 2. So This runs until the condition I press my reset button. When I press my reset button, what happens is it again starts from the beginning. It starts counting from the beginning. From that, 1000 milliseconds is considered, and then I will be getting my next one value. So this is my program for running my particular LCD interface with Arduino. I hope this is clear. And to conclude, this is the resistor value that was available over here. So to change this particular resistor value, if I change it to a higher value, for example, say 10 kilo ohm, as I told you, higher resistance means lower current. Lower current means my brightness is going to be reduced. So I will be getting a very dim particular value over here. Now when I stop this particular program and I change my resistor back to a higher, lower value, say for example, the previous 220 ohm value, what is going to happen is my brightness of my particular display is going to increase. So I hope you understand the value of my resistor over here, and this potentiometer, as I told you earlier, is when I change this potentiometer value, it will the contrast of this particular display is going to change. Either it will go 0 or it will go to 1. So this is my particular LCD interface with